Ever get that feeling that large language models are, doing amazing things, but you're not quite sure how to tell if they're really hitting the mark?
Mm-hmm.
They can draft emails, summarize docs, even debug code, right? But what does good actually look like under the hood? That's sort of the puzzle we're tackling today.
Yeah.
We've got a stack of really fascinating insights here, all focused on this crucial topic of LLM evaluation.
Absolutely. It's easy to be wowed by what feels like magic with LLMs, isn't it?
Yeah.
But for them to be genuinely useful and reliable, we really need to move past just intuition.
Right.
We need concrete ways to assess how they're performing for specific tasks. It's not just about, is the output factually correct in isolation?
Mm-hmm.
You got to consider the whole context, the timing, the format, and crucially, making sure they stay within, acceptable boundaries.
Exactly. So whether you're maybe prepping for a meeting about the latest AI stuff or just trying to get a handle on this field because it moves so fast.
It really does.
Or maybe your curiosity is just piqued about how these complex systems are actually measured. Understanding LLM evaluation gives you a real shortcut. It helps you get well-informed pretty quickly.
Definitely.
And you know what? Our sources highlight some truly innovative tools being used, and one that really jumped out at me is W&B Weave. It sounds like it gives you these incredible superpowers to actually see what's going on with these evaluations. We'll absolutely be digging deeper into that.
Well, yeah, Weave is definitely worth talking about. It helps manage all this complexity. But fundamentally, our mission here in this deep dive, it's about extracting the essential bits, right? The why and the how. We put these powerful models to the test.
Okay.
It's about getting past that initial wow factor and into the practical methods that make sure they deliver real value.
Okay, so let's jump right in then. Why is it so vital that we rigorously evaluate LLMs? It's not just some academic exercise, is it?
No, not at all. Think about it like this. You've made some adjustments, right? Maybe tweak the model, change the prompt. How do you know, really know if those changes actually made things better? That's the first key reason. Validating quality improvements.
Right. You need proof.
Exactly. Evaluation gives you the data, the measurable results, to confirm your efforts are actually leading somewhere positive.
That's such a critical point. You wouldn't want to roll out a change that accidentally makes the system worse, would you?
Precisely. Which flows right into the second crucial point, detecting regressions early.
Ah, okay.
Imagine a new version of your model suddenly starts making stuff up more, hallucinating more, or maybe it just gets really slow.
Yeah, that'd be bad.
A good evaluation setup will catch those negative changes during testing before they hit your users and start eroding trust.
Catching problems before they escape into the wild, that seems incredibly valuable for keeping things reliable. What else? What other key benefits does evaluation bring?
Well, it lets us quantify performance across a whole range of metrics. We're not just going on a gut feeling of, is it good or bad? Evaluation lets us put actual numbers on things like how relevant are the responses? How often does it make factual errors? Is there any toxic output? Even how fast does it give you an answer?
So you can basically compare different models or maybe even different ways of prompting the same model, but objectively.
Exactly. That's the power of being able to benchmark alternatives. You use consistent, measurable criteria.
Okay.
You can test Model A against Model B on the same tasks and see which one performs demonstrably better according to the metrics you care about. Same goes for trying different prompting techniques. Which one gives you the best results?
Okay, so it helps you pick the right tool for the job, essentially. What about when the system gets weird inputs, unexpected stuff?
Yeah, that's where ensuring robustness comes in. Real users, they'll inevitably interact with your system in ways you didn't predict.
Ah, definitely.
They'll give weird prompts, hit edge cases.
Right.
Evaluation helps you see how well your LLM handles those curveballs. Does it still give useful, safe outputs even when things get strange?
And I imagine in a lot of applications, maybe sensitive ones like finance or health, safety is just huge.
Oh, absolutely critical. Maintaining trust and safety is basically non-negotiable there, right?
Mm-hmm.
In healthcare, finance, education, evaluation helps you spot if the model tends to generate harmful stuff or biased content or maybe insecure outputs.
So you can put safeguards in place.
Exactly. You can mitigate those risks.
So it's really about making sure these incredibly capable tools are not just effective, but also, responsible.
Precisely. Our sources really emphasize this. LLMs have amazing abilities, but their behavior can sometimes be unpredictable. Rigorous evaluation brings that much-needed reliability and transparency into the whole development process.
Right.
It turns the LLM from this kind of black box into a system with performance you can actually define and measure.
That makes perfect sense. Now, the material we've looked at talks about a pretty big shift, doesn't it? How evaluating LLMs is different from traditional software testing. What's the core difference there?
Yeah, this is a really fundamental distinction to grasp. Traditional software testing, think unit tests, integration tests, usually deals with deterministic code.
Okay, predictable.
Right. You give it input X, you expect output Y. Every time. With LLMs, though, we're mostly evaluating dynamic behavior, not fixed predetermined answers.
Dynamic behavior. You mean like how it understands nuance, generates relevant stuff, stays coherent?
Exactly that. We're assessing how the application responds to a whole spectrum of inputs, often in real time. The focus shifts to things like, does it get the context? Is the language clear and logical? What's the overall user experience like? It's less about checking if one specific answer matches perfectly.
That sounds, well, a lot more complex, more nuanced than just checking if code returns the right number.
It is. The material uses a great analogy, actually. Think of it like supervising a human trainee versus testing a calculator.
Okay.
For the calculator, the test might be, what's 2 plus 2? The answer is always 4. For an LLM, the test might be, respond helpfully to this angry customer email.
Ah, right. No single correct answer there.
Exactly. But we can still evaluate it, right?
Yeah.
Did the response address the customer's problem? Was the tone right? Was the info accurate?
So the focus shifts from matching an exact output to meeting certain criteria for quality and effectiveness, like a checklist.
Precisely. Teams often develop checklists or scoring rubrics for LLM outputs.
Yeah.
Does it use the context? Does it avoid harmful stuff? Is it formatted correctly? Some of these checks you can automate with code.
Okay.
Others might need another AI or person to judge. But the basic principle is the same as traditional testing. Make sure the system works as intended and delivers value consistently. We're just adapting how we evaluate for these unique LLM characteristics.
Okay, that really clears up the mindset shift. Now let's get practical. The sources talk about different types of LLM evaluations. Let's start with this one. LLM as a judge. Sounds like AI policing AI.
It is a pretty fascinating idea, and it's becoming more common. LLM as a judge basically means using one LLM to evaluate the output of another LM.
Whoa, meta.
Yeah. So instead of just relying on humans, you craft a specific prompt for a second LLM, telling it how to assess the quality of the first one's response.
How does that actually work, though? Like, practically?
Usually you design a pretty detailed evaluation prompt. It gives the evaluator LLM clear rules. For example, you might tell it, you are an impartial judge. Here's a user query and the model's answer. Rate the helpfulness from 1 to 5 and explain why.
Okay.
Then for each test case, you feed the evaluator LLM the original question and the first model's answer. It spits back a score and maybe a reason.
So what's the big win here? Why have an AI judge another AI instead of just using people?
The main advantages are scalability and consistency. Getting humans to annotate tons of data is slow, expensive, and sometimes, well, people judge things differently. Right?
Subjectivity.
LLMs can be like always on, relatively cheaper evaluators compared to huge human teams anyway. And they can apply the rules more consistently, especially with massive data sets. It's really useful for those subjective things where writing exact code rules is super hard.
That makes a lot of sense, automating a chunk of QA. But how reliable is it? Can we really trust one AI to judge another one fairly?
That's a really good question. And the honest answer is it heavily depends. It depends on how good the evaluator LLM is, and critically, how clear and well-designed your evaluation prompt is.
Right, garbage in, garbage out, potentially.
If the judge model is biased, or the prompt is vague, the judgments won't be worth much. Plus, there's the cost and delay of making another LLM call for every single evaluation. But research and real-world use show that if you do it thoughtfully, LLMs can be surprisingly good judges. They often agree pretty strongly with human ratings on things like factual accuracy or relevance. Even OpenAI apparently uses LLM judges a lot internally.
Wow, okay. That's a pretty strong endorsement. So when is using an LLM judge most useful?
It really shines when you're evaluating those subjective or high-level qualities where it's tough to write strict code rules. Like, does the answer really get at the user's intent? Is the tone right for the situation? You can even use them for comparative evaluations. Give the judge LLM 2 different answers to the same question and ask it which one's better based on these criteria.
So this could be a really fast way to iterate on different models or prompts.
Exactly. LLM judges get used a lot before production to quickly label big data sets. If you have tons of test prompts but no perfect answers yet, you can use an LLM judge to get a first pass, a rough score of how your model is doing across the board.
Sort of generating a quick ground truth.
Kinda, yeah. A synthetic score or label. Of course, it's always smart to double-check some of those AI judgments with humans, just to make sure the evaluation itself is sound.
Okay, fascinating stuff. A scalable approach. What's the next method the sources cover?
The next big one is code-based LLM evaluations. This brings us back closer to traditional software practices. You use programming logic, actual code, to check the LLM's output.
Ah, okay. So instead of another AI making a judgment, you're writing explicit rules in Python or whatever.
Precisely. A simple example. Say your LLM is supposed to output JSON with specific fields. A code-based test could just parse the output and check. Is it valid JSON? Are all the required keys there?
Right. Or maybe checking a math answer.
Yeah, exactly. If the task is arithmetic, your code could extract the number from the LLM's text response and compare it to the known correct answer.
What are the main upsides of doing it this way, with code?
Several big ones. First, there's no extra cost or latency from calling another LLM API. It's all just your own code running.
Cheaper and faster.
Yep. Second, these tests are deterministic and reproducible. Same input, same output, the test always gives the same result. That makes them perfect for plugging into your CI/CD pipelines. It's just like regular unit tests.
Ah, okay. Automation.
Right. They run fast, scale well. If you can clearly define your success criteria in code, this is often the most efficient way to go.
Sounds great for objective, structured tasks. Where does it fall short? What are the limits?
Well, the main limitation is pretty obvious. Not everything about language is easy to check with code. These tests work best for tasks with one right answer, or a very specific format.
Mm-hmm.
But for more subjective things, like how insightful is this summary? Is the tone right? It becomes incredibly hard, maybe impossible, to write code that reliably captures that human-level judgment.
Yeah, you'd basically be trying to code up good taste or something?
Pretty much. In those cases, you're usually better off with an LLM judge or actual human evaluation.
So it's great for checking the what's facts format, but not so good for the how quality style.
That's a pretty good way to put it. In practice, lots of teams use code-based checks as a sort of first pass, an automated sanity check.
I like a quick filter.
Yeah. Like if the LLM is meant to call an API and return data in a specific structure, you write code to assert that the structure is correct. Common uses are checking formats, schemas, looking for specific keywords, or making sure it doesn't break on known examples where you do have a defined correct output.
Sounds like a really valuable first line of defense. Catches the basic mistakes, make sure things are structurally sound.
Exactly. And the sources make a good point here. When writing these tests, it's usually better to check for properties or patterns rather than demanding an exact string match.
Why is that?
Because LLMs can say the same thing in many different ways, right? If your test expects exactly the answer is 42, it might fail if the LLM says the result is 42. So checking for the number 42 is more robust than matching the whole sentence.
Makes sense. Avoid brittle tests. Okay, so we've got AI judging AI and traditional code checks. What's the next big distinction in evaluation methods?
The next really important split is between online and offline evaluation. This is all about when and on what data you do the evaluation.
Okay, online versus offline. Let's break that down. What's offline evaluation mean for LLMs?
Offline LLM evaluation happens in a controlled space before you deploy or update your model in the real world. Think development, testing phases.
Okay, pre-production.
Right. You evaluate the LLM's performance on a static, pre-existing data set, like doing lab tests before you release a product.
So you've got a set list of test prompts and maybe ideal answers, and you run the model against those.
Exactly. These curated sets are often called golden data sets or benchmark data sets. They're carefully built to cover the main tasks and tricky edge cases you expect the model to see later.
And the benefit is?
Consistency. By testing on these fixed data sets, you get a clear picture of how the LM does on known examples, and you can easily see if performance improved or got worse compared to last time you tested.
I see. So it's mostly about validation before deployment, catching problems in a controlled way.
Exactly. Offline evaluation is also crucial for experimenting, trying different prompts, tuning model settings, even comparing completely different base models side by side.
Because it's repeatable.
Right. You can run these tests again and again and objectively see which setup gives the best results on your benchmark data. Lots of teams bake offline evaluation right into their CI/CD pipelines.
So it runs automatically with changes.
Yep. A suite of automated tests runs every time code changes. giving you that early warning if something broke.
That sounds like a vital safety net before anything goes live. So then, what's online evaluation? When does that happen?
Online LLM evaluation happens after your LLM app is deployed and interacting with real users in production. It means continuously monitoring the LLM's outputs and interactions using live data.
So watching how it behaves in the wild with real usage.
Precisely. Online evaluation is focused on runtime behavior and system health. You might set up dashboards tracking key metrics like how often do users complain about answers, or how often does the system flag potentially harmful output.
So you can spot problems as they happen.
Yeah, if a key metric suddenly tanks after a new deployment, you get an alert right away.
That makes sense for immediate issues. What else does online evaluation involve?
Well, it also lets you directly integrate real user feedback, maybe simple thumbs up, thumbs down buttons on responses.
Oh, okay. Explicit feedback.
Right. Or even implicit signals, like does the user immediately ask the same question again in different words? That tells you something. Yeah. Getting that direct user feedback into your metrics is incredibly valuable for understanding the real experience.
I can see that.
And online evaluation also enables A/B testing in production.
Trying out changes on a small group of users.
Exactly. You deploy a new model or prompt to, say, 5% of users and compare live metrics, user engagement, task success rates against the old version. It lets you make data-driven decisions about what actually works better in the real world.
That's super valuable, getting performance data from actual use. Are there big challenges with online evaluation, though?
Oh, definitely. A primary one is cost and performance. Running complex evaluations, especially if they involve more LLM calls, on every single user request can get expensive fast, and it can slow things down noticeably.
Right, adds overhead.
So teams often have to be clever about what they evaluate online. Maybe they only evaluate a random sample of interactions, or they do the heavier evaluations asynchronously after the user already got their response.
So it sounds like the best bet is probably using both online and offline together.
Exactly. The sources really stress that. Ideally, you use both. Offline is your pre-flight check, ensuring a baseline quality. Online is your in-flight monitoring, catching issues that only show up with real usage over time.
A combined approach.
Yeah, and having a unified system where you can use the same evaluation logic both offline and online, that's really powerful for consistency and getting a complete picture.
Okay, that gives a really good overview of the different evaluation types. Now, the material also makes a distinction between LLM model evaluation and LLM system evaluation. What's the difference there?
Yeah, this is a really key distinction, especially if you're actually building stuff with LLMs. LLM model evaluation is about assessing the general capabilities of the base LLM itself, kind of in isolation.
Like, how smart is GPT-4 overall?
Pretty much. This is usually what researchers and the big model developers focus on. They benchmark foundational models, GPT-4, Llama, whatever, across a wide range of standardized academic tasks, measuring core skills like language understanding, reasoning, general knowledge.
So gauging the raw potential of the underlying engine, separate from any specific application.
Exactly. The metrics here are often things like perplexity, how well it predicts the next word, or accuracy on standard benchmark data sets like MMLU or GLUE. The key is, it's not tied to a specific product. It's about the model's intrinsic abilities, usually with default settings.
Okay, got it. Evaluating the raw engine. So what's LLM system evaluation then?
LLM system evaluation, sometimes called task evaluation or application evaluation, is focused on assessing the model's performance within the context of your specific application.
Ah, so how it works in your product.
Precisely. This is what matters most to practitioners building things. It takes into account everything you control. The specific prompts you wrote, any RRAG system or tools you hooked up, any post-processing you do on the output.
Right, all the surrounding pieces.
System evaluation answers the question. Given how we've set this LLM in our system for our purpose, does it actually do the job well?
So it's evaluating how well the engine performs once it's in a specific car, being used for a specific kind of driving, like, say, off-roading versus highway cruising.
Exactly. Perfect analogy. A base model might ace all the general benchmarks, but it might not actually be the best fit for your specific app. Maybe a smaller, fine-tuned model, or one integrated with a really good retrieval system, actually works better in your context.
That makes total sense.
Our sources strongly suggest that if you're building an application, your main focus needs to be on evaluating the entire system, the LLM, plus all the stuff you added around it.
Right, because the general benchmarks are interesting, but what really matters is how it performs in your use case, with your setup.
Absolutely. The big companies using LLMs heavily, They tend to have their own internal suites of system evaluations tailored specifically to their products. They might watch the general benchmarks when thinking about upgrading the base model, but they rely on their own system tests for validation day to day.
Okay.
The key takeaway: model evaluation shows general capability, but system evaluation is what actually predicts user satisfaction and the success of your specific application.
Okay, so we know what to evaluate the whole system and why to make sure it works for our specific needs. Now, how do we actually measure that performance? What are some key LLM system evaluation metrics?
Right, the how. The specific metrics you pick will really depend on what you're trying to achieve with your application. But there are several common ones that pop up across many use cases.
Let's dive into some of the big ones. The material starts with relevance. What's that about?
Relevance, or sometimes appropriateness, basically asks, does the LLM's answer actually address the user's question or the task at hand?
Seems fundamental.
It is, especially for things like chatbots or Q&A systems. You often measure it simply relevant or irrelevant, or maybe on a scale. If relevance is low, the model might be misunderstanding the user or just not being helpful. And in RAG systems, relevance also includes checking if the model actually used the information it retrieved correctly.
Makes sense. Got to answer the question asked. What about the opposite problem when the AI just makes stuff up?
Yeah. That brings us to the critical metrics of factual accuracy and hallucination rate. Super important for anything dealing with knowledge.
Right.
You're basically measuring how often the model says things that are factually wrong or just completely fabricated. You usually check this by comparing the output against reliable sources or a known ground truth.
So checking if it's telling the truth, basically.
Yeah.
Based on known facts.
In essence, yeah. Then you've got correctness, which is sometimes called task success. This is a bit broader. It asks, did the model actually achieve the goal of the task? Like, if you asked to solve a math problem, did it get the right number? If you ask for code, does that code compile and run correctly? Often you can evaluate this by comparing to a known correct answer or by running automated tests on the output, like running the generated code.
Okay, so task level accuracy. What if the user asks for something complex with multiple parts?
That's where completeness comes in. An answer might be factually right in the parts it covers, but still bad if it leaves out crucial information or ignores part of the user's request.
Okay. Didn't answer the whole question.
Right. Measuring completeness often needs human judgment, or maybe checking if certain key elements are present in the response.
We've talked content and accuracy. What about just how well is it written? The language quality.
Good point. That falls under coherence and fluency. Coherence is about logic. Is the response well structured? Does it make sense overall? Fluency is about the language itself. Is it grammatically correct? Does it sound natural?
And how do you measure that?
Fluency is usually pretty good with modern LLMs, especially in English. Coherence can be trickier. Sometimes people use automated scores like Perplexity or Blue Rouge as proxies, but honestly, human rating is often needed for a really good assessment here.
Okay. What about applications where you might want the AI to be more creative, offer different ideas?
That relates to diversity of outputs. For brainstorming tools or creative writing aids, you might want to measure if the model generates varied responses and avoids just saying the same thing over and over.
How do you check for repetition?
There are metrics like self-BLU. A lower score means more diversity. But it's worth noting, for many business applications, you might actually prefer consistency and predictability over lots of diversity.
Good point. Okay, shifting gears a bit speed. How do we measure that?
Latency. Simple but crucial for user experience. It's the time from request to response.
Just average time.
You want to track the average, yeah, but also higher percentiles, like the 95th or 99th percentile. That tells you about the worst case delays and helps ensure consistently responsive field.
Got it. And you also want to make sure the model is reliable, behaves predictably.
Absolutely. That's robustness and consistency.
Yeah.
Robustness is about handling noisy or slightly varied input well. Consistency is about giving similar quality answers to similar questions, even if phrased differently.
And not contradicting itself.
Right. Avoiding contradictions within a conversation or over time is also part of consistency.
And of course, safety. We mentioned it before, but it's a metric too.
Huge one. Safety and toxicity metrics measure if the model outputs harmful, biased, or inappropriate stuff. This often uses specialized classifiers like the OpenAI content filter or Perspective API to flag bad outputs. The goal is usually to get the rate of these unsafe outputs as close to zero as possible.
And ultimately, doesn't it all boil down to whether users are actually happy with it?
You could argue that, yeah. That's user satisfaction. You can measure it directly asking users for ratings running surveys.
Or indirectly.
Or indirectly by looking at behavior. Do users keep coming back? Do they successfully finish tasks using the AI? While it's maybe a broader product metric, it definitely reflects the real-world effectiveness of your LLM system.
Wow, that's a lot of different angles. It sounds like the main thing is picking the metrics that really matter for your specific goals with the app.
Precisely. The sources basically say, start with a few core metrics that are absolute critical for your application's success, then maybe add more as you need them.
Can you give an example?
Sure. Say you're building a RAG system for customer support. You might start by focusing on the relevance of the documents it retrieves, right? Then is the answer it generates actually grounded in those documents? Is the answer factually correct? And is the language fluent? Those might be your initial key metrics.
That helps tie it together. Okay, this is a lot of different ways to measure things. The sources mentioned an LLM evils comparison chart. What are the big takeaways from that summary?
Yeah, the chart basically drives home the point that no single evaluation method is perfect. They all have pros and cons, like LLM as a judge. Great for scaling subjective checks, but its quality depends entirely on the judge LLM. Code-based checks. Super reliable and cheap for objective stuff, but useless for nuance.
And humans.
Human annotation gives you the best quality judgment for tricky subjective things, but it's slow and expensive, doesn't scale well. And user feedback is gold for real-world insight, but it can be noisy and slow to collect.
So the best approach is usually mixing and matching, a layered strategy.
Absolutely. The chart really points toward the multi-layered approach. Combine techniques to cover your bases, maybe use humans to create a great benchmark data set, then use an LLM judge to evaluate against that data set at scale, and add code-based checks for the basics like format or specific facts.
Okay.
And this, I think, is where the real excitement comes in for tools like WNB Weave, because managing all these different layers can get messy, right?
I can imagine.
But these platforms, like Weave, they're built specifically to help orchestrate this. Think about defining your evaluation criteria once, and then being able to easily run those checks offline on test data, and maybe even plug them into your live production monitoring.
Wow, okay. Seamless transition.
Yeah. And they let you combine scores from multiple types of evaluators, your code checks, your LLM judge scores, maybe even human feedback, and track everything over time in dashboards. It makes comparing different model versions or prompts so much easier, seeing how they stack up across all your important metrics. It's like having a proper mission control for LM quality.
That sounds incredibly useful, just keeping everything organized and giving you that clear picture across different methods. Okay, so what about the steps before you even launch? What does pre-production evaluation look like?
Right, pre-production evaluation. This is all about laying a solid foundation before you go live. The main focus here is building those high-quality test data sets and benchmarks we talked about.
The golden data sets.
Exactly. Often involves curating golden data sets, maybe with human annotation, to ensure they're accurate and cover both normal use cases and tricky edge cases. Teams might also use synthetic data generation, using rules or even other AIs to create more test examples just to get better coverage.
What else happens pre-production?
A huge step is establishing baseline metrics. Run your first version of the model and prompts against your test data and record how it does. That's your starting point.
Something to measure against later.
Right. Then comes iterative tuning. You look at the evaluation results, tweak your prompts or model settings, and retest. See if you improve things. And finally, benchmarking and alignment, making sure the team agrees on what good enough looks like, and that the model actually behaves the way you want before it sees real users.
So it's like really rigorous QA, but specifically designed for AI before you let it out the door. What happens once it is live? How does evaluation fit into the ongoing development cycle?
That's where CI/CD for LLM apps comes in. Continuous integration, continuous deployment. It's about baking evaluation right into your regular software release process. Well, automating evaluation in your CI pipeline is key. Every time someone commits a change to the LLM system, those golden dataset tests should run automatically.
Catch regressions fast.
Exactly. And again, tools like WB Weave are just fantastic here for the experiment tracking piece. Every time you try a new prompt, a different model setting, you log the experiment, log the evaluation results. Then you can easily visualize and compare, did this change actually improve metric X? Did it hurt metric Y?
So you have a clear record of what worked and what didn't.
Precisely. You also need deployment guardrails, maybe canary releases, roll out changes to just a small % of users first, watch the metrics closely, then go wider if things look good. And of course, versioning and reproducibility are vital. Always being able to know exactly which model, which prompt, which code version produced a certain result.
It sounds like bringing the discipline of modern software engineering to AI development.
That's the goal. Continuous improvement, but with the confidence that comes from having automated quality checks.
And even after it's fully deployed, evaluation isn't done, right? It keeps going.
Absolutely not done. Production LLM evaluation is an ongoing thing. It's about maintaining and improving quality while the app is live.
What does that involve?
Setting up real-time guardrails, trying to catch harmful or bad outputs before they reach the user. It involves continuous monitoring and alerting on your key metrics. If latency spikes or toxicity flags go up, you need to know now. Integrating those user feedback loops we talked about is also crucial in production. Real user input is invaluable for finding areas to improve. And generally, monitoring the ongoing performance and stability, making sure things don't degrade over time, may be due to concept drift where the real-world data changes.
And there are tools specifically for this production monitoring phase.
Yes. Specialized tools for AI observability, the sources mentioned, Weave again, but also Arise, Langfuse, YLabs. These platforms are built for monitoring LLM outputs in real time, detecting anomalies, and helping you understand what's happening in production.
It really sounds like a continuous cycle. Evaluate, monitor, improve, repeat. Now, looking ahead a bit, the sources mentioned this cool idea of self-improving LLM evaluation. What's that about?
Yeah, that's a really neat forward-looking concept. Self-improving LLM evaluation basically means evaluation systems that can automatically get better at their own job over time.
How would that work?
Well, imagine the evaluation system learning from the kinds of mistakes the main LLM makes. If it keeps messing up on, say, math problems, the evaluation system might automatically start testing math more rigorously in the future.
Ah, okay. Adapting its focus.
Or it could use feedback loops where the evaluation results are fed back to automatically fine-tune either the main model or the evaluation criteria themselves, maybe using few-shot prompting or dynamic prompt updates to make the LLM judges more accurate over time.
So, less manual effort to keep the evaluations relevant.
That's the idea. To make the evaluation process itself smarter, more adaptive as the LLM system evolves. It's like the evaluator becomes a student of the model's behavior, constantly learning how to test it better.
That's a really cool concept, the evaluation getting smarter alongside the model. Okay, finally, the sources touched on how evaluation might differ depending on the specific LLM use case. Can you quickly walk through some of those nuances?
Sure. The best approach really needs tailoring. For our RAG systems, you have to evaluate two things: the quality of the retrieved info and the quality of the final generated answer, especially making sure the answer is grounded in the retrieved stuff.
Right. 2 stages to check.
For LLM-based agents, things that can use tools and take actions, you need to look beyond the final answer. How was its reasoning process? Did it use the tools correctly? How did it handle errors?
More complex process evaluation.
Exactly. Yeah. For chatbots and conversational AI, you care about factual accuracy, sure, but also consistency of persona, overall user satisfaction with the conversation flow, handling different chat contexts.
More about the interaction quality.
Right. For content generation, human judgment often takes center stage for things like creativity, style, engagement, though you can still use automated metrics for coherence or readability. And for code generation, you lean heavily on automated tests. Does the code compile? Does it pass unit tests? Does it meet requirements? Security checks, too.
So each use case really have its own critical metrics and challenges.
Definitely. You need to tailor your evaluation strategy accordingly.
This has been incredibly insightful. It's just so clear that a really thoughtful, rigorous approach to LLM evaluation is absolutely essential if you want to build AI systems that are dependable, safe, and, actually useful.
Precisely. And like we've discussed, it's not one size fits all. It really requires that careful mix of methods before and after deployment, always focused on the specific goals and hurdles of your application.
So for anyone listening who's working with LLMs or thinking about it, getting a solid grip on these evaluation concepts seems, critical.
It really is. It gives you the framework to figure out not just if your LLM is working, but how well and why it's performing the way it is.
And it leaves you with a big question too, doesn't it? As LLMs get woven more into our lives, how are our own definitions of quality or even intelligence going to change? And how will we keep refining our evaluation methods for these increasingly complex systems to make sure they actually serve us well and ethically? That's definitely something to chew on. Thanks so much for breaking all this down with me today.
My pleasure. It's a fascinating area, constantly changing, always more to learn.